What is robots manipulation? A definition of robotic manipulation has been provided by Matt Mason as: manipulation refers to an agent's control of its environment through selective contact. Robots need to manipulate objects, pick up, modify, destroy, or otherwise have an effect. Thus, the functional end of a robot arm intended to make the effect, whether a hand or tool, are often referred to as end effectors, while the arm is referred to as a manipulator. Most robot arms have replaceable end effectors, each allowing them to perform some small range of tasks. Some have a fixed manipulator that cannot be replaced, while a few have one very general-purpose manipulator, for example, a humanoid hand. What is robots manipulator? In robotics, a manipulator is a device used to manipulate materials without direct physical contact by the operator. The applications were originally for dealing with radioactive or biohazardous materials using robotic arms, or they were used in inaccessible places. In more recent developments, they have been used in diverse range of applications including welding automation, robotic surgery, and in space. It is an arm-like mechanism that consists of a series of segments, usually sliding or jointed, called cross slides, which grasp and move objects with a number of degrees of freedom. In industrial ergonomics, a manipulator is a lift assist device used to help workers lift, maneuver, and place articles in process that are too heavy, too hot, too large, or otherwise too difficult for a single worker to manually handle. As opposed to simply vertical lift assists, cranes, hoists, etc., manipulators have the ability to reach into tight spaces and remove workpieces. A good example would be removing large stamped parts from a press and placing them in a rack or similar dunnage. In welding, a column boom manipulator is used to increase deposition rates, reduce human error and other costs in a manufacturing setting. Additionally, manipulator tooling gives the lift assist the ability to pitch, roll, or spin the part for appropriate placement. An example would be removing a part from a press in the horizontal and then pitching it up for vertical placement in a rack, or rolling a part over for exposing the back of the part. What are robots grippers? A common form of robotic grasping is force closure. Generally, the gripping mechanism is done by the grippers or mechanical fingers. Two-finger grippers tend to be used for industrial robots performing specific tasks in less complex applications. The fingers are replaceable. Two types of mechanisms used in two-finger gripping account for the shape of the surface to be gripped and the force required to grip the object. The shape of the finger's gripping surface can be chosen according to the shape of the objects to be manipulated. For example, if a robot is designed to lift a round object, the gripper surface shape can be a concave impression of it to make the grip efficient. For a square shape, the surface can be a plane. Though there are numerous forces acting over the body that has been lifted by a robotic arm, the main force is the frictional force. The gripping surface can be made of a soft material with high coefficient of friction so that the surface of the object is not damaged. The robotic gripper must withstand not only the weight of the object but also acceleration and the motion that is caused by frequent movement of the object. To find out the force required to grip the object, the following formula is used. F equals ma by qn, where F equals the force requires the object, m equals is the mass of the object, a equals is the accelerator of the object, q equals is the coeffect of the fraction, n equals is the number of fingers in the gripper. A more complete equation would account for the direction of movement. For example, when the body is moved upwards against gravitational force, the force required will be more than that towards the gravitational force. Hence, another term is introduced and the formula becomes F equals m a plus g by qn. Here, the value of g should be taken as the acceleration due to gravity and a the acceleration due to movement. What is robotics tweezer? Tweezers are small tools used for picking up objects too small to be easily handled with the human fingers. The tool is most likely derived from tongs, pincers, or scissors like pliers used to grab or hold hot objects since the dawn of recorded history. In a scientific or medical context, they are normally referred to as forceps. Optical tweezers, originally called single-beam gradient force trap, are scientific instruments that use a highly focused laser beam to hold and move microscopic and sub-microscopic objects like atoms, nanoparticles, and droplets in a manner similar to tweezers. If the object is held in air or vacuum without additional support, it can be called optical levitation. The laser light provides an attractive or repulsive force, typically on the order of piconewtons, depending on the relative refractive index between particle and surrounding medium. Levitation is possible if the force of the light counters the force of gravity. The trapped particles are usually micron-sized or smaller. Dielectric and absorbing particles can be trapped too. Optical tweezers are used in biology and medicine, for example to grab and hold a single bacterium or cell like a sperm cell, blood cell or DNA, nanoengineering, and nanochemistry to study and build materials from single molecules, quantum optics and quantum optomechanics to study the interaction of single particles with light. The development of optical tweezing by Arthur Ashkin was lauded with the 2018 Nobel Prize in Physics.